This book is titled Software Engineering at Google. What precisely do we mean by software engineering? What distinguishes software engineering from programming or computer science? And why would Google have a unique perspective to add to the corpus of previous software engineering literature written over the past 50 years? The terms programming and software engineering have been used interchangeably for quite some time in our industry, although each term has a different emphasis and different implications. University students tend to study computer science and get jobs writing code as programmers. Software engineering, however, sounds more serious, as if it implies the application of some theoretical knowledge to build something real and precise. Mechanical engineers, civil engineers, aeronautical engineers, and those in other engineering disciplines all practice engineering. They all work in the real world and use the application of their theoretical knowledge to create something real. Software engineers also create something real, though it is less tangible than the things other engineers create. Unlike those more established engineering professions, current software engineering theory or practice is not nearly as rigorous. Aeronautical engineers must follow rigid guidelines and practices because errors in their calculations can cause real damage. Programming, on the whole, has traditionally not followed such rigorous practices. But as software becomes more integrated into our lives, we must adopt and rely on more rigorous engineering methods. We hope this book helps others see a path toward more reliable software practices. We propose that software engineering encompasses not just the act of writing code, but all of the tools and processes an organization uses to build and maintain that code over time. What practices can a software organization introduce that will best keep its code valuable over the long term? How can engineers make a code base more sustainable and the software engineering discipline itself more rigorous? We don't have fundamental answers to these questions, but we hope that Google's collective experiences over the past 2 decades illuminates possible paths toward finding those answers. One key insight we share in this book is that software engineering can be thought of as programming integrated over time. What practices can we introduce to our code to make it sustainable, able to react to necessary change over its life cycle, from conception to introduction to maintenance to deprecation? The book emphasizes 3 fundamental principles that we feel software organizations should keep in mind when designing, architecting, and writing their code. Time and change. How code will need to adapt over the length of its life. Scale and growth. How an organization will need to adapt as it evolves. Trade-offs and costs. How an organization makes decisions based on the lessons of time and change, and scale and growth.